Number 9631. It's Kira Bobrovnikova, Sergey Lysenko, Oleg Savenko, and Ivan Kurman. IoT Cyberattack Detection approach based on energy consumption analysis. Please, who will be present? Okay. Professor Sergey Lysenko, yes? You will.
Okay, do you hear me, colleagues?
Yes, we hear and we see you. Please, you have time for your presentation. Welcome.
Okay, dear colleagues, I'm very happy to be here. And unfortunately, my colleague, Kira Bobrovnikova, is unable to make this presentation, so this mission will be on my way. Okay, I'd like to briefly to present our team results concerning IoT Syberattack Detection approach. And today it's a very interesting idea to make the detection based on energy consumption analysis. So of course, today, Internet of Things and smart home consumption have become an important part of modern society. On the other hand, the growing number of IoT devices, which are often released without any security features, make them a desirable target for cyber criminalists. So, since the limited battery capacity of smartphones does not allow them to be used for profit, that smart TV, set-top boxes, and other IoT devices are popular with cybercriminals. In this regard, cybercriminals create new malware for these devices. As we can see, the new families of IoT malware are being detected recently. Also, unprotected IoT devices join the ranks of botnet that are most often used to launch DDoS attacks or as VPN exit nodes. Also, crypto mining is another popular way to monetize compromised IoT devices. The availability in security of IoT devices has led to a rapid increase of the number of IoT cyber attacks in recent years. Despite the large number of different developed methods for detecting and preventing of IoT cyber attacks, IoT devices is still incredibly vulnerable and suffered a wide range of cyber attacks. So there is a great need to develop new ideas, new approaches for malware and cyber attack detections. And today we'd like to present some ideas for detection based on energy consumption monitoring as a possible way to detect those performing attacks which require significant energy consumption. For example, DDoS, crypto mining, and so on. Okay. So we propose technique which is try to analyze the IoT device energy consumption. And to do this, I propose to organize and develop some footprints. And that footprints are based on a set of IoT users preference modes for some IoT device. Also, this model includes devices, set of devices in network, a number of devices. We have to define the energy consumption related to user prefers mode, such as temperature, lighting, humidity, air quality modes, etc. And we deal with energy consumption control function, which keep up the energy consumption. We take into account current energy consumption and in certain mode and under the attacks. So idea includes two stages because it uses some machine learning algorithms. So it has learning and testing stages. So the learning stage of the energy consumption analysis includes such stages as footprints construction for different related users preference mode in the absence of the attacks. The next step of the stage is we have to also construct footprints based on energy consumption in the presence of a cyber attack. Also, we have to normalize and label data. After that, we have to construct labeled and unlabeled data metrics for each IoT devices. And we execute learning of some classifiers. Later, we used several of them by using the labeled data metrics of the IoT devices energy consumption footprints. The next step, we have to test the classifier using unlabeled data metrics of the IoT device energy consumption footprints. And of course, we have to evaluate the efficiency of the obtained results. And to do this, to construct footprints of the energy consumption, we use some measures, and we have to normalize them for whole of IoT devices at the point in time at the absence of IoT cyber attacks, and as well as when we have such attack. And we take into account a number of measurements in some time interval. Here you can see the procedure of energy consumption footprint construction. Of course, it's based on the user's preference modes. Then we form set of devices which are analyzed, and for all of them we have to construct footprints, taking it into account different user preference modes. And after that, we have to construct footprints based on absence of cyber attacks and its presence. After that, we normalize all data, and as the result, we have labeled data and unlabeled data, which are ready for its classification. Okay, and another idea concerning cyber attacks, when we take into account energy consumption, we have possibility only answer a question that is something is going wrong. Maybe we have an attack, but how to localize which exact IoT device is compromised and what may be the point from what the attack is executing. So to do this, we involved another approach. So to do this, we propose action sequence analysis. So it's some behavioral approach in order to localize where exactly the DDoS, for example, attack is performing. So to do this, also this approach has two stages: learning and testing. And the first one has such steps. The first one, it's assembly representation extraction for the benign and malicious IoT binary executables. After that, we have to represent actions as maximal sequential pattern mining in all the binary executable assembly. After that, using that patterns, we are able to construct future vectors. And after that, we are eager to evaluate the relevance for each of the selected maximal sequential patterns. And the next step is to perform labeling and construction of future vectors of actions of every maximal sequential patterns relevance to each binary executable assembly representation. After that, we are able to construct label and unlabeled data metrics of the feature vectors, and to do this we can use different classifiers using that obtained matrix. And the next step is to test classify using unlabeled data matrix of feature vectors of the maximal sequential patterns. And after that, we have possibility to evaluate the efficiency of the action sequence analysis. Okay, to do this, here you can see some mathematical base of maximal sequential patterns concerning our feature vectors. And here some math concerning how we can evaluate relevance, for each of the selected maximal sequential patterns. To do this, we can use mutual information, frequency of each actions, type of class which is executed, and also we use joint probability distribution function, and as well as marginal probability distribution functions to calculate that needed relevance. Okay, here is sum up of the steps. We are dealing with benign, set of benign and set of malicious binary executables. After that, we perform assembly representations for each of them, and after that we use MSP for all of them. After that, when we obtained its value, we can sort them, evaluate relevance, and obtain feature vectors. Based on that, we are eager to obtain labeled and unlabeled data for its further classification. Okay, the most important part of the research, of course, it's efficiency assessment. So to do this, we used a set of classifiers. We used some measures as accuracy and as well as F1 score. And so to do this, we tried decision trees, random forest, k-nearest neighbors, and extreme gradient boosting algorithms in order to make classification. As you can see, we have three types of the research. When we applied only the energy consumption analysis, when we use only software behavior analysis, yes, as we can see, the efficiency is pretty low. When we use only the energy consumption analysis, when we use only behavioral approach, results are about 80%. But when we combine both of them, when we can, using the energy consumption analysis, find out that there's something is going wrong, yes, and taking into account what behavioral analysis, we obtain very good results for this. So you can see two part of results of accuracy values as well as F1 score values for these results. And as we can see, also combination of two approaches. We are talking about energy consumption and behavioral analysis, and demonstrates very good results. So here you can see conclusions, but I'd like better to hear questions. Thank you for your attention.
Thank you very much for your presentation. It is one of the direction how we can get additional information to more accurate detect cyber attacks. And now we have short time for questions. Welcome.
Well, I've got one question, Alexander.
Alexander, welcome.
Well, it would be interesting to know if you considered peculiarities of assessing wireless IoT products energy kind of measurement, because as you know, radio brings a little too big uncertainty into power management and power assessment. So it will be interesting to know if you looked into that as well.
Actually, not yet, but thank you for a good idea. Yes, because yeah, wireless technologies, it's a great part of the IoT infrastructure, and yes, we have take a look at that part, but we didn't do it yet. Thank you for your idea for our next level of research.
Thank you for question and answer. Any other questions? No, thank you very much. One more for your interesting presentation.